Hi, my name is Suryanarayana. I'm a senior full stack developer cum trainer in CDC IARE. Today is the continuation to the last iostreams topic. The last iostreams topic, I've explained about the difference between byte streams and character streams, ASCII range characters and Unicode range characters. Byte streams means reading and writing ASCII range characters. Character streams means reading and writing Unicode range characters. Byte stream means ASCII range characters. That means from reading from 0 to 127, 128 to 255. To 0 to 255 characters in the ASCII chart. Reading those characters, this is reading stream of bytes, because 1 byte memory is sufficient to hold the ASCII range character value, each character in the ASCII range. Coming to the Unicode range, 0 to 65,535. So in order to hold the Unicode value of each Unicode character in the Unicode range, to hold that, we need 2 bytes of memory. So that is nothing but reading stream of characters. So in iostreams API, input-output streams are given to deal with byte streams, and reader-writer classes are given to deal with character streams. Except that there is no major difference between, including in the programming also, there is no difference between input-output streams programs and reader-writer programs. Programs absolutely remain same. It all depends on which range characters we read and write, and for that, which input-output streams or reader-writer classes are used. That you have to determine. And today's topic is data input stream and data output stream. In the last class, we have covered file input stream and file output stream. In that, we read each character ASCII value from the file. Check whether that ASCII value is not equal to -1 or not. Not equal to -1 means if the read character is not equal to -1, then there is something exists in the ASCII value, 0 to 128, 255, 0 to 255. If character ASCII value is between 0 to 255, it is fine. If there is no character to read from the file, the read method of the file input stream will return -1. If -1 comes, that means we reach to the end of the file. That was the condition in file input stream. And subsequently, we have written into file output stream. Coming to the data input stream, why we are coming to the data input stream is because in case of file input stream, reading from file using file input stream and writing into file using file output stream, for smaller files is okay. Like files which are in couple of bytes to couple of KBs to less than MBs. But if the file size is in couple of MBs or GBs or more than that, reading and writing each and every character or byte by byte is very expensive. They may consume disk I/O operation calls, or they may consume network I/O calls, or they may consume some other input-output calls. So in the Java I/O package, under filtered input stream class, under input stream class, so many input streams classes exist. Filtered input stream class exists. Under filtered input stream, data input stream, buffered input stream, all the input streams exist here. So there is a subclass name called data input stream that is under filtered input stream. Its purpose is to read data of various data types. Actually, this data input stream should be called as data type input stream, because the read methods in data input stream are right from read byte to read short, read int, read long, read float, read double, read char, read boolean, up to read line. But there is one read method exists for every primitive data type, right from byte to read byte, read short, read int, read long, read float, read double, read char, read boolean, read line. Read line is specially used for reading line by line, that means strings. So hence, because for each data type one read method is given in this class is named as data input stream, but originally it is supposed to be in data type input stream, because for every data type one read method exists in this class. So data input stream I am using for reading line by line, and data output stream along with file output stream I am using here to write data line by line into file. First of all, what we should do is to read data from the file. We should create one new object of new file input stream. What is the argument in file input stream? The argument in file input stream is file name. Any existing file name. File should be already present in your hard disk. Then only we can give that file name as argument into file input stream class constructor. Suppose if you give a wrong file name, or if you give correct file name, but with that file name, the file does not exist in the local hard disk. Maybe the application previously ran in my machine. I brought that application to some other machine, so where that file does not exist. So, because of unavailability of the file, or file name wrong, or unavailability of the file, if the file does not exist, file input stream immediately throws file not found exception. File not found exception, FNFE. File not found exception. So fine. That is why to handle all the exceptions, as I told you in the earlier videos, you always keep the exception suspected block of code into try-catch block. So try-catch block, catch with single exception E would be enough. Actually, you should handle the iostreams programs with the catch, file not found exception, IO exception, and then followed by common exception A. Okay, and the file input stream object we are not taking into separate reference. That object we are directly passing into data input stream class constructor. Okay, data input stream specialty is to read byte by byte, int by int, long by long, float by float, double by double, line by line, but don't know from where to read the data from. Data input stream specialty is to read various data types in each read operation. But data input stream doesn't point to any input source. Similarly, file input stream. File input stream can read data from the file, but it can read byte by byte. It cannot read byte, long by long, int by int, float by float, double by double, line by line like that. So that is why we are combining the features of both the file input stream and data input stream into one single object. We created data input stream object. Now, data input stream points to file input stream points to file name. Okay. Similarly, we created one data output stream and file output stream also. Data output stream device is equal to new data output stream of new file output stream of student data underscore new.txt. File output stream class will never throw file not found exception because file output stream always writes data into file. If the file already exists, the data will be overwritten from the beginning of the file. If file does not exist before, it will create a new file. So, new file creation or existing file overriding is what file output stream will do. So, file output stream class constructor doesn't throw file not found exception. File input stream class constructor throws because there you are giving the already existing file name. So, please remember. But anyway, we need to keep pure block of code in try-catch block because during input and output operations, both read and write, some IO exceptions may arise. So, because of maybe suddenly some hard disk failure or the communication link with input device and output device failure, something may happen. That's why we need to handle IO exception. Okay. Next line, first line, second line, third line. I'm not counting the class, main method, and try-catch block lines. Okay. I'm reading first line, data input stream dot read line. String line is equal to data input stream dot read line. First line is read. What we should check? If file already contains a file data 1 ampersand ABC like that, 2 ampersand XYZ, 3 ampersand element, 4 ampersand PQR like that. Data exists in the file. Okay, we are reading the file. First line is read. So that line will come. Suppose if the file is blank, if there is no content in the file, let us assume. During the first read itself, the read line method will return null. And if there is nothing to read from the file, data input stream dot read line method will return null clearly. If there is something to read from the file, then that content will be returned to string. So here we are checking the condition. If line is not equal to null, if line is not equal to null means there is something in the file there's something in the line also. If line is not equal to, if line is null, please quit the value. Please come out. So if it is not null, using SOP, system.out.println, we are printing one copy of the line on standard output. One copy should be returned to file. So which method must be used? File output stream must be used generally. File output stream.write method. But file output stream.write method will take the character's ASCII value, but not the whole line. Not even takes it takes ASCII character. It will take only ASCII value of the character. So don't expect that method in file output stream. So that is why we engage them in file output stream with the data output stream. Data output stream is also having similar methods. One write method to write different data values. Write byte, write short, write int, write long, write float, write double, write char, write boolean, write bytes. Here method is not write ln or write line, write bytes. Write bytes to write chars. For ASCII characters, write bytes. So for write chars, for ASCII Unicode characters. Correct. So that's what write bytes. There is no write line or write ln method is given because character maybe within the ASCII range or Unicode range. We don't know. That's what. So data output stream that write bytes function will take string. Write bytes means array of bytes means nothing but array of characters, nothing but string only. So the argument of write bytes method is line. Once it is done, again you read second line. Again, line is equal to same variable we are using here, string line, the same variable we are using here. Line is equal to data input stream dot read line. But before, between each read and write operation, we are sleeping the program for 100 milliseconds. 1000 milliseconds is equal to 1 second. 100 milliseconds means 1/10 of the second. So that is how you calculate. And at least we'll be able to see the output on the monitor. If you don't give sleep, within no time, the program will start execution and finishes also. We cannot see that line by line reading and writing. We don't feel of, seeing how the line has been read and returned to the file. So that's why we are giving the sleep and with some duration here. After that, the recently opened object should be closed first. Data output stream should be closed first. And then early opened object, data input stream object must be closed. So we need not have to close file output stream and file input stream because they're already there inside data output stream and data input stream. DOS and DAS are closed. Close followed by catch exception E dot print status. So if any exception comes, please print it. If you are interested, please print the exceptions if an exception comes. Otherwise, just comment this E dot print stack trace. So the exception comes, they will not be printed. So this program may possibly throw exception only if the student details.txt file does not exist in your system. If it exists, this new file will be created. This is about copying file line by line. Okay. Previous program is copying file byte by byte. This is line by line. This is copying file. This is buffer by buffer. Buffer by buffer. What does it mean? Why is this needed? Because remember, in the previous example, in the data input stream, from student details.txt file, we read each line and we wrote each line into another file, student details_new.txt. If file is a text file, in the text file, there will be an end of line at the end of every line. That's called as newline character, \n. So text files contain newline at the end to bring control to the second record, second student record. Again new line, again third record, new line, again fourth record, new line, and so on. Each record is stored into one line in the text file. So that's why in the file previously using readline method, we read each line up to until we encounter newline character. So that is reading line by line. But if you want to read data from non-text files like binary files like image, audio, video, PDF, Word document, Paint, Excel, various other zip file, jar file, movie, audio, video, wave, various extension of files. Nowadays, the PDF documents are available in some Amazon Kindle device format, sometimes EPUB format, sometimes some other different formats. The documents are available, PDF documents or documents to read. So those documents are all binary files; they are not text files. Then how to read and write data to and from such files, where there is no end of the file representation. Then in such cases, suppose for example, 1024 bytes is equal to 1 KB. Okay, 1024 KB. And 2 KB is equal to 2048. I'm not going to calculate anything here, 2048. Suppose if the file is some 15 KB or 30 KB. Sometimes it may not be 30 KB, 29.5 KB or 29.52 KB, something like that. Or some 27.2 KB. That is the issue. So, if the file size is 30 KB, or sometimes the file size may be 29.52 KB or 27.2 KB. So, if the file is having that much of data, and that the data is not having any Newland character to read line by line, how this much of data can be read at a time? Suppose if it is 27.2 KB, 27.2 into 1024 bytes is equal to 1 KB. You calculate those many number of bytes. And there's some 27,000 something comes. I don't exactly remember. And 30 KB means 30,000 characters plus. Characters is some binary data of the data. Reading 20, 25, 27, 30,000 bytes at a time into buffer. Maybe in large computing systems, that much memory may be available. But in the intermediate systems and ideal systems, programmer systems may not have that much heap memory available to read 30,000 characters at a time or 50,000 characters at a time or 100,000 characters at a time. So then what exactly you can do is, you do one thing. First of all, take the file size. So for that, what I did, in this example, you are using buffered input stream, buffered out stream demo. Buffered input stream, buffered out stream. Buffered input stream will read buffer. Buffered output stream can write buffer by buffer. Remember, for that sake, we are using buffered input stream and buffered output stream. It's not line by line. Okay. This copying file buffer by buffer, because of due to characteristic came as copying file line by line, having buffer by buffer. So for that, what we have to do is, we'll discuss about these two lines later on. In order to first of all find out the file size, there is one class given in the Java.io package called file. File f is equal to new file of. File class constructor will take file name as argument. Chrysanthemum.jpg. Chrysanthemum.jpg is correct. That is one of the flower in our Windows, that downloads images from somewhere. It's available. Chrysanthemum image. Okay. So first of all, one file object is created that is pointing to chrysanthemum.jpg. Okay, fine. Now pointing to that file class is having one method called length. File class is having one method called length. The length method is going to give the length of the file. The length of the file in a form of bytes. Suppose if it is 27.2 KB, 27.2 KB, 27.2 into 1024 bytes, number of bytes comes, that number of bytes it will give. If it is 29.52 KB, 29.52 into 1024 bytes, those many number of bytes will be written to this length. That's why the written about the length method is not an int. So because the file length may be more than the int range, so that's why length method written type is long length. SOP, we are writing SOP just for debugging sake. Okay. So after doing that, what exactly we are doing is, we got the size like some 29,000 something 50 to 29.52 into 1024, something like that. Okay, like let us assume 35,000 or 3,000 something. I don't exactly get that. You have to calculate it. You find out the size of the file. In order to read that much of data, how to read that much of data is you give, suppose, say for example, 30,000. 30,000 you give divided by 1,024 you give. 1,024 if you give, you will get some 30.0 something. That is the issue. 30 point something, 30 point something, or 31 point something it will give. So that means by doing this division, we can determine how many number of times we can iterate a for loop. Those many times, each time we'll read 1,024 bytes of data at a time into buffer, and how many number of times we are reading 1,024 bytes of data every time into the buffer is, it all depends on the value given by the number of bytes divided by 1,024. That will give how many number of times the loop want to be iterated to read 1 KB at a time, to read the whole file. That logic is written here. Length divided by size. Size is already declared as 1,024 there. Length is nothing but the size of the file. So that is usually the division values always comes as a double value. Double value we are printing. Suppose if it is 31 or 30 point something 5 to 4 something like that, we should round about it to 31. The 30 point, if anything cross, we should read 31 times. If it is 30.000, then 30 times something. 30 point something, even if one single byte is extra there in the file, we should read 31 times. So here math dot seal. Seal in sense like, it will give upper bound value. 30 point something if you give, it will give 31. If you give the math dot floor, it will give 30 point something 5 to something, it will give the lower bound value, 30. So we are making it 31. How many number of lines we want to read. So the next, the double value we are converting into int. How to convert double value into int? Double we want to convert into int. So double you can type as into int, no problem. But through upper classes if you do, double value should be always wrapped into double object. New double of d length. Double value is wrapped into double object. Double object dot int value method if you call. So it will convert it. Anyway, you type as directly double value into int. Int number of iterations is equal to typecast into int d length. Enough. All this is not required. So the number of iterations will come. So here we are iterating on for loop for I is equal to 0. I is less than number of iterations I plus plus. Here inside for loop I am creating one byte array. A blank byte array is the size of 1,024 bytes. And this byte array is only every time 1,024 bytes when buffer input stream reads, that whole data is stored into this byte array only. Now what we should do is, an empty byte array is created, but no data is added. Go to the previous slide. Here we created one buffer input stream object that is pointing to file input stream object that is pointing to chrysanthemum.jpg, comma size. Size means we are telling byte input stream, please whatever may be the whatever may be the file and file size it is having, you read only 1,024 bytes of data. And the buffer input stream class read method was clearly given in instruction that you read only 1,024 bytes of data. Similarly, buffer output stream and file output stream, that is also pointing to one more file, chrysanthemum 1.jpg. No, we should not give the same file. 1.jpg, comma, you give the same file size. Today you are asking buffer output stream to always write 1,024 bytes of data into that file. Not 30,000, 50,000 bytes at a time. Okay. 1 KB of data. Okay, 1,024 bytes of data at a time. Okay. Now what you do is, go to the next slide. You read buffer input stream.read off. You give this blank buffer byte array. Byte array B initial is blank. It's having a 0 bytes. It is having 1,024 bytes of one byte array is created, but whose all its values are 0 by default. Once you give it to read method, the byte array, this will be filled with 1,024 bytes of data right from the buffer input stream. Buffer input stream pointing to file input stream is pointing to chrysanthemum.jpg. From that, 1,024 bytes of chrysanthemum.jpg is stored into this byte array that we are giving to buffer output stream.write. I forgot to write one more line here. once again we should not required. For loop again create one more blank binary, and every time binary is becoming destroyed, and every time it's creating a new one. Into that again next 1024 bytes of data is returned. Again new binary, again read, again new binary, again read, and again read. Like that, the number of iterations are as per the calculation we made here. Depends on the file size divided by 1024 bytes. Yeah. So the division logic will calculate how many number of iterations are required. Once entire operation is completed, we are closing buffer out stream and buffer input stream objects. So binary streams must be written in this way. Character streams must be character-based files. Can be read using data input stream. Binary files must be read using buffered input stream. We can use file input stream directly, byte by byte, or buffer by buffer through buffered input stream and buffered output stream. Once after completion of this topic, we'll enter into one more topic called object serialization. What is the purpose of object serialization? Object serialization purpose is like there are various purposes where object serialization is used. One is in standalone Java programs. In standalone Java programs where we feel storing the data into database is expensive. Like, so for example, we are having straightforward student data, or straightforward employee data, or student attendance data, or student projects data. When no relational data exists as such, plain one particular entity data is there, student or employee data, that we want to store and retrieve always from the file. We don't want to store and retrieve from the database. We want to store the student data or employee data into a file. Objects are created in the application. At the end of the application, the objects must be stored into file. Every time and next time the application restarts, the data should be loaded from the file again. All previous employee objects should be loaded again, and application should continue. Again, if any new objects are created at the end of the application, all the objects must be written to hard disk. Again, when next time application restarts, the whole data must be again, all the objects must be again read from the hard disk to again into employee objects. So if you want to do like that, or even object serialization can be used in the networking, not can be used or used in the network applications majorly. If an object want to transmit from one system to another system, one GVM to another GVM, they must serialize and go, and should be deserialized on other system. But here we are not using networking application, we are using simple iostream application. So in this application, altogether we are having one class employee, one client program that will create an array of employee objects, maybe 5 or 10 employee objects manually or maybe dynamically. Those many employee objects are created. This client one, what it does is, once after creating array of employee objects, this client program will write all the objects into serializable file. And this program doesn't demonstrate like why we need serialization. This program demonstrates how to do serialization and how to do serialization. So where practically we use it, that we can discuss later on in the projects, in the networking applications or in the standard applications. In the place of database, we can use the serializable files as a temporary database. Like that. So from this serializable file, we'll write one more client program that will read all the serialized objects stored in the serializable file again back into the program. And however list of employee objects are created here in client 1 system, these objects are as it is restored back into client 2. Distributed applications, networking applications, standalone applications, everywhere we'll use this object serialization and deserialization. Very, very important topic. But nowadays object serialization importance got little bit reduced because of the XML, the arrival of XML and JSON. And XML and JSON are also going to do the same thing. They also got converted from object into XML or JSON format so that they can move from one system to another system like maybe a .NET or COBOL or C++ or C or C Sharp or Python or PHP or mainframes or mid-range or SAP. So any other system it will go. XML, JSON, they are not Java object serialized format. They can be understood by other programming languages and other technologies. They can deserialize the XML and JSON data and they can store it into their own respective language objects. So let's start with the object serialization topic. So whenever you're writing an object serialization topic, first of all, you start with a bean, like which objects you want to store it into file and which objects state you want to read back from the file. So we want to use employee class, public class employee. Always whenever you're writing a class whose objects want to be stored into serializable file, remember the class must be declared as public. And the class must be implemented from java.io.serializable file, serializable. Don't forget this. If you don't implement employee class from serializable, your objects will not be serialized at all. You'll get a cannot serialize exception. But during serialization, you won't get any error. During deserialization, you are trying to get the objects. No objects are serialized, no objects will be deserialized. You will get a blank output. So remember always. So you always implement the classes whose objects want to be stored into hard disk. Their objects state want to be stored into hard disk. They must be implemented from serializable interface. Okay, it's just only marked interface. No methods serializable interface contains, but object output stream class is having a write object with. Who does object serialization? In Java, many people misunderstood that JVM will do object serialization and JVM will do deserialization. Absolutely not. JVM will never participate in object serializations and deserializations. That's specially conducted by two classes called object output stream and object input stream. Object output stream is capable of writing objects state as is into files. Object input stream is having the ability to read object states as is from the file. Only these two input output streams can do that. That other normal, other streams cannot do it. So, implement class from serializable interface. Declare employee number, employee name, salary, designation, normal as usual variables. Usually, you declare these variables as private. Write one parameter constructor, write one parameter constructor. Write one pair of setter and getter methods for each variable. If there are 4 variables, you write 8 total setter and getter methods. Send 4 pages of setter and getter methods. They're all common while writing the bean. You two strings, written employee number, employee name, salary, designation. This is generally how the normal beans are written. So you create even 1 object, 10 objects, 100 objects, 1000 objects, 10,000 objects. When you serialize all these objects, their whole state, then every object, employee number, employee name, salary, and designation is nothing but the object state. The whole data will be stored in a serializable file. Remember, if this class contains employee number, employee name, salary, designation want to be stored, but if this employee class contains any confidential data may be something such as bank account number, marital status, or PAN card number, Aadhaar card number, bank pin code number, any of that kind, like credit card number or passport number or any of that kind, like my marks percentage, my grade, which I don't want to expose to others. So how do you do that? It's like if any variables in an object want to be excluded from serialization, you will declare such variables as transient. Transient means which are not persistent, are called as transient. You declare variables as transient so that those transient variables are excluded from the object serialization. So then next, once B is completed, what I'm doing is I created one serializable demo class, created 4 objects, employee ID, employee name, salary, designation, and in the constructor you please include bank account number also. You please include here 1001, 1002, 1003, 1004. They are not serialized number because that variable which is holding these values is a transient. Constructor is having account number, but here I forgot to pass the account number. I created one file out sim, object out sim. File out sim is pointing to employee.serializable file. File out sim is given to object out sim. So object out sim dot write object of. Each object is given here. Here access relation is taking place. When you are giving object into this write object method, this method will internally check whether this even is an instance of serializable or not. If this instance is not an instance of serializable, then that object will not be serialized. Object serialization will fail. And who checks the condition whether the object can be serialized or not is object of sim dot write object method. Once this program is completed, in the hard disk you'll find employee.serializable file. If you open that file and see, all these 4 objects are found in a serialized format, which Java, which we cannot read. Only object serialization format can read it. So, predict deserialization program. In this program, what I am doing is opposite way. File input sim pointing to employee.serializable file using object output sim pointing to file input sim. How many objects we have written to file? 4 objects. So 4 times we are writing object input sim to read object, read object, read object. Each object coming from the file, we know what type of object it is. It is an employee object. We are typecasting into employee object, taking into 4 references, E1, E2, E3, E4. We are printing all the 4. Finally, object input sim is closed and file input sim is closed. So this is how the data of any student or employee can be stored into hard disk for a very longer period in the absence of, in the absence of databases. If you don't want to use databases with file system, if you want to maintain the objects. So this I feel like this object serialization is one kind of, mini database kind of mechanism. Next time we make our own practical example on using this object serialization format. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.